Hello everyone, welcome back to series of basic concepts of chemistry. This is part 2. In this video, we are going to discuss atomic weight, particularly that is relative atomic weight, absolute atomic weight, relation between relative atomic weight and absolute atomic weight, and the exact meaning of gram atom. This is our discussion. So complete clarity we need to get. So here, before going to the exact determination of atomic weight by using different scales, here I just wanted to give one simple example. After understanding this example, after discussing this example, atomic weight concept can be understood very easily. So here we have a table like this, and we need to measure the length of this table. So our aim is measuring length of this table. In order to measure length of this table, I'm using a device that is a standard scale. I'm using a standard scale, and here this standard scale, here it is exactly, it is 30.48 centimeters, but approximately let me take 30 centimeters. Instead of saying every time 30.48 centimeters, let me say this is 30 centimeters. Instead of this 30 centimeters, you can say 12 inches. This scale, that is 12 inches. Or instead of that, we can also say this is 1 foot. So this is 1 foot. So this is the standard scale we are using, and our target is very simple: measuring length of this particular table. In order to measure the length of this particular table, I am using this scale. So I'll be using this scale, and I will be measuring the length of this table, and after completion of the measurement, simply our result is like 5 scales. So here our result is, what is the length of that table means, we'll be saying 5 scales. 5 scales. See, whatever the length you are giving, you are expressing, that is relative length. Relative length. So here relative length. So by taking this scale into consideration or reference, you are reporting your answer as a 5 scales. But what is the length of this particular scale? That is 30 centimeters. And if you say 5 into 30, that will be 150 centimeters. 150 centimeters. Otherwise, 5 into 1, we can say 5 feet. So whatever it may be. So this is the general example I have discussed to explain the concept of relative atomic weight and absolute atomic weight. Relative atomic weight and absolute atomic weight. Here, what is the relative length of this table? So 5 scales. 5 scales. That means the actual length of the table, or original length of the table, or absolute length of the table by length of this scale. That is equal to 5 scales. So based on this particular example, let us try to understand the concept of atomic weight. See, now we have some sophisticated techniques to measure the mass of atom. Actually, atom is a smallest particle. The measurement of mass of that particular atom is very difficult. Now it is easy, okay, because we have some sophisticated techniques like mass spectroscopy. But in olden days, that is in 19th century, before 19th century, so here these techniques were not available. Mass spectroscopy, these kind of techniques were not available. Therefore, the scientists used some reference elements to measure, to indicate the mass of atom. Here we are taking this scale as reference, right? So this is 30 centimeter long scale we have taken as reference scale. Similarly, before 19th century, the scientists used some reference scales to express the mass of atom, and let us get into the details of atomic and molecular masses. But first, let us complete the concept of atomic mass. So, but in 19th century, scientists could determine the mass of one atom relative to another by experimental techniques. They have taken different reference elements, like sometimes they took hydrogen as a reference element, oxygen as a reference element, but I'm not discussing all those things at present. In periodic table, whatever the atomic masses we have, they were determined by taking carbon as reference element, C12. So C12 means, so the mass of carbon atom, so the mass of carbon atom, that is 12, and that is the meaning of a C12. Here I have written that is a C12. So this is carbon, and the mass of carbon is 12. Simply here, in place of C12, if you imagine that scale in the previous example, whatever the scale we have taken, if you assume that particular scale, you will be very much comfortable. The reference scale we have taken, what is the length of that reference scale? 30 centimeters or 12 inches. Here also, what is the reference element we are taking? Carbon. What is the mass of carbon? 12. So here, a mass exactly 12 AMU, atomic mass unit. In this IUPAC scale, so this is the standard scale, International Union of Pure and Applied Chemistry, and according to that scale, carbon 12, the mass is exactly 12 AMU. Whatever the scale we have taken in the previous example, what was the length we have taken? 30 centimeters. Here also, here the same thing you have to imagine. What is its mass? 12 AMU. 12 AMU. What is the full form of AMU? Atomic mass unit. AMU, atomic mass unit. So what is the exact definition of AMU? See, in this 1 AMU definition we are trying to give. Here we have carbon 12. The mass is 12 AMU, but I want 1 AMU. I want 1 AMU. But what is the mass of this C12? 12 AMU. I want 1 AMU. Simply, very simple, you have to take 1/12 part of 1/12 part of 1 carbon 12 atom, 1 atom of carbon 12. See, in the earlier example, I took a scale whose length is 30 centimeters. For example, if you want to define 1 centimeter, so what does it mean? So 1 by 30th part of that scale, because that scale has 30 centimeters. I need 1 centimeter. So you have to divide that scale into how many parts? 30 parts. Same thing. We have a reference element. Reference element is carbon. The mass of one carbon atom is 12 AMU, but I want to define 1 AMU. I want to define 1 AMU. I have carbon 12, carbon atom. What is its mass? How much? What is the mass assigned? 12 AMU. But what is my requirement? 1 AMU. So divide that carbon atom into 12 parts. Practically, it is not possible. We are just giving the definition, right? So 1 AMU is defined as a mass exactly equal to 1/12 part of 1 carbon atom. You take 1 carbon atom, the assigned mass is 12 AMU, divide this carbon atom into 12 equal parts. After dividing this carbon atom into 12 equal parts, Each part mass is 1 AMU. That is the meaning of AMU. That is the meaning of AMU. So 1 AMU is 1/12th part of C12 atom. C12 means carbon, assigned mass is 12, right? This is clear. And interconversions, very important. So 1 AMU is equal to 1.66. Exact value from NCERT have taken, but for calculations you can take 1.66. This part you can neglect, no issue. 1.66 into 10 power minus 24 grams. If you want to convert the mass from AMU to grams, you have to multiply wherever you see AMU. Wherever you see AMU, if you want to convert that into grams, simply replace AMU with 1.66 into 10 power minus 24 grams. 2 AMU, 2 into 1.66 into 10 power minus 24 grams. Carbon, if you take 12 AMU, 12 into 1.66 into 10 power minus 24 grams. 100 AMU, 100 into 1.66 into 10 power minus 24 grams. And here, if you want to replace this grams with kilograms, you have to write 10 power minus 3. 10 power minus, already 10 power minus 24 is there. You're writing 10 power minus 3, and that becomes 1.66 into 10 power minus 27 kilograms. Till completion of your final exam, whatever it may be. So it may be mains, advanced, NEET, whatever. Till completion of your final exam, you should remember this. So 1 AMU is 1.66 into 10 power minus 24 grams, 1.66 into 10 power minus 27 kilograms. And what are the other names of AMU? It is also known as avogram. I will tell you why it is avogram. It is also known as Dalton. And the latest symbol for AMU, the latest thing given for AMU, that is unified mass. Instead of atomic mass unit, we can say simply U, which means unified mass. This is the meaning of AMU, right? Now, let us define the atomic mass. I already told you, older scales I'm not taking. Hydrogen scale, oxygen scale I'm not taking. I'm taking IUPAC scale, right? IUPAC scale. What is the exact meaning of atomic mass? Atomic mass of any element is the number which indicates that how many times the element is heavier in comparison to 1/12th part of C12 isotope. So let us understand this particular definition again with this example, because giving clarity is important for me. I may take some time, but you should get the complete clarity. Here, you are measuring the length of this table. In order to measure the length of this table, you used a reference scale whose length is 30 centimeters. 30 centimeters. And see, for example, let us take, this is 150 centimeters. Let's assume this is 150 centimeters. Let's assume nothing wrong. And what is the length of this scale? 30 centimeters. And what is the meaning of 1 centimeter? 1 by 30th part. 1 by 30th part of this scale, standard scale. So this table is 150 times longer when compared to 1 by 30th part of this scale. Why? 1 by 30th part means if you divide this scale into 30 equal parts, if you divide this scale into 30 equal parts, that is actually called 1 centimeter. That is called 1 centimeter. And this table is 150 centimeters. So what does it mean? This table is 150 times longer when compared to 1 by 30th part of this scale, right? Based on this, let us understand the definition of atomic weight according to atomic. Yesterday also, in the previous video also, I told you atomic weight, atomic mass. In case of chemistry, there is no much difference, but initially I cleared. Sometimes I'll be saying atomic mass, sometimes I'll be saying atomic weight. So consider that is mass only. So atomic mass of any element in the periodic table is a number. Oxygen atomic mass 16, sodium atomic mass 23, helium atomic mass 4, calcium atomic mass 40, potassium atomic mass 39. So what are these things? Atomic mass of any element is a number. What does it indicate? That number indicates how many times that element is heavier in comparison to 1/12th part of C12 isotope. How many times that element is heavier in comparison to 1/12th part of C12 isotope. That table is 150 times longer when compared to 1 by 30th part of that standard scale, because that scale is 30 centimeters long. 1 by 30th part is nothing but 1 centimeter. Similarly, here the reference element is carbon 12. 1/12th part of C12 isotope is 1 AMU. When compared to this 1/12th part of C12 isotope, how many times that element is heavier? Oxygen is 16 times heavier. Nitrogen is 14 times heavier. Calcium is 40 times heavier. So these are all reference masses. So that's why I'm saying it is a relative mass of an atom. It's a relative. Earlier also in that example, length of the table, that is a relative length. You are saying that by using that scale you measured and you reported your answer as 150. That means that table is 150 times longer. So here also that element is oxygen is 16 times heavier, nitrogen is 14 times heavier. So it is a relative mass of an atom. It is not an exact mass, it is a relative mass. And it is a simple number and it has no units. Simply there, what did you say? 150 times. When you are saying relative length, you are simply saying 150 times. When compared to 1/12th part of C12 isotope, our oxygen is 16 times heavier. So 16 times. Nitrogen 14 times. Calcium 40 times. Helium 4 times. Right? So it is a simple number and it has no units. And what it is? This relative mass of an atom is absolute mass of an atom by 1/12th part of C12 isotope. Mass of an atom of the element, actual mass divided by 1/12th part of C12 isotope, which is nothing but AMU mass. Already told you 1/12th part of C12 isotope is what? AMU mass. So relative atomic weight is numerically equal to absolute atomic weight by 1/12 part of C12 isotope, which is called AMU weight, AMU mass. So atomic mass of an element, when nothing is mentioned, this is relative only, IUPAC scale. So mass of one atom of the element, mass of one atom of the element is nothing but absolute mass by AMU mass. If you know relative atomic weight, if you know relative atomic weight, you can find the absolute atomic weight. For example, again, I'm going back to that example. Table length is 150, you said. 150. You said 150. What is 150? That table is 150 times longer when compared to 1/30th part of that scale. So 150 times you are saying, and 1/30th part of that scale is nothing but 1 centimeter. Now what is the absolute length of the table? 150 centimeters. Similarly, knowing the atomic mass of an element, that means this mass, the absolute mass of an atom can be determined. So from this equation, you can, absolute mass you can find. So absolute mass is equal to, bring this 1/12 part of C12 isotope left side. So absolute mass is equal to relative mass into 1/12 part of C12 isotope. What does it mean? AMU. 1/12 part of C12 isotope is nothing but what? AMU. And AMU mass is converted into grams, 1.66 into 10 power minus 24 grams. So absolute mass of an atom, absolute mass of an atom is equal to relative mass of an atom into AMU mass. And AMU mass, that is according to IUPAC, 1/12 part of C12 isotope is AMU. And if that is expressed in grams, 1.66 into 10 power minus 24 grams. Of course, we also have some older scales, hydrogen scale. So before IUPAC, hydrogen scale. So the absolute mass of an atom by mass of one hydrogen atom. But when we take hydrogen as reference, we take mass of one hydrogen. But in IUPAC scale, 1/12 part of C12 isotope we are taking. So this is atomic mass according to which scale? Hydrogen scale. Oxygen scale, absolute mass of an atom by 1/16th part of O16 isotope. But this is only for the information sake I'm giving, but don't be confused with all these things. You take a IUPAC scale. So 1 AMU definition, other names of AMU, how to convert AMU into grams, kilograms, that numerical, that relation, and the relative atomic weight, what is the definition? Once relative atomic weight is known, how to find the absolute atomic weight, absolute atomic mass, absolute atomic weight is equal to relative atomic weight. This is known from that experiment, any experiment, but here in that earlier we have done, that is not experiment, we just measured the length. Similarly, by using various experiments, we have to find the relative atomic mass. And after knowing the relative atomic mass, if it is multiplied by 1.66 into 10 power minus 24, you will be getting absolute mass of that atom. In which units? Grams. Which units? Grams. Right? So these are some older scales. Now, one more term we have, that is gram atomic mass. See, definitions are very much important. Definitions are very much important. So relative atomic mass means, relative atomic weight means it is a number which indicates that how many times that atom is heavier in comparison to 1/12 part of C12 isotope. Absolute weight of an atom. Absolute weight of an atom. So this is weight of one atom. That means relative atomic weight into AMU weight. According to IUPAC, AMU weight is nothing but 1/12 part of C12 isotope. Now we have another term, that is gram atomic mass. gram atomic mass. So it is the mass of not a single atom, it is the mass of Avogadro number of atoms. It is the mass of Avogadro number of atoms expressed in which units? Grams. It is the mass of Avogadro number of atoms expressed in grams. So Avogadro number, this one also you should remember, and till completion of your final exam. So many times you will be getting this 6.022 into 10 power 23 exact value, but you can also take 6.023, no issue. Once whatever the differences generally we come across, here only I'm clearing 6.022 or 6.023, it makes no difference, right? Avogadro number 6.022 into 10 power 23, dozen 12, half a dozen 6. Similarly, Avogadro number Avogadro number 6.022 into 10 power 23. So what is our term here? Gram atomic mass. What is the definition of gram atomic mass? It is basically the mass of not single atom, Avogadro number of atoms expressed in which units? Grams. Expressed in which units? Grams. So it is the absolute mass of course, Avogadro number we can also say 1 mole. 12 we can say 1 dozen. 6, the number 6 we can say half a dozen. 100 we can say century. 50 we can say half a century. Similarly, 6.022 into 10 power 23, we can say 1 mole. 1 mole, that is 1 mole. So here my requirement is gram atomic mass. It is the mass of how many atoms? Avogadro number of atoms. So first let me take atomic mass into AMU mass, because this is the absolute mass. Atomic mass, AMU mass. So this product is actually called what? Absolute mass. AMU mass means according to IUPAC 1 AMU only, right? And it should be expressed in which units? Grams. So AMU mass is 1, very clear. Don't be confused, because we are in IUPAC scale. AMU mass is 1. How? 1/12 part of C12 isotope, right? And this AMU is converted into grams, 1.66 into 10 power minus 24. But this is not the mass of single atom. This is the mass of Avogadro number of atoms. So it is also multiplied with Avogadro number. So you just multiply, you will get 1.66 into 6.023. If you take the product of these two, you will get 10. If you multiply, you'll get 10. So 10 into 10 power 23, 10 power 24, 10 power 24 into 10 power minus 24, that is equal to 1. That is equal to 1. So numerical values are same, but the units are different. You check. See, here if you take absolute mass of one atom, if you take absolute mass of one atom, if you take, this is the absolute mass of one atom. But we are taking how many atoms? Avogadro number of atoms. Avogadro number of atoms. Therefore, so AMU value is 1. This is 1.66. Already told you 6.023. The product is 10 into 10 power 23, 10 power 24. 10 power 24 into 10 power minus 24 means 1. Therefore, gram atomic mass is equal to atomic mass into 1 gram. Oxygen. What is the atomic mass of oxygen? 16. Atomic mass of oxygen is 16. Gram atomic mass of oxygen is 16 into 1 gram. But there is so much difference, no? So 16 grams means this is not the mass of single atom. This is the mass of Avogadro number of atoms. right? One more important term we have, that is gram atom. Gram atom. Gram atom. So what is the meaning? Gram atomic mass of any element is also known as 1 gram atom. Gram atomic mass of any element is also known as 1 gram atom. See, for the sake of explanation, I'm taking 1000 grams. 1000 grams is equal to 1 kilogram. Similarly, you take some amount of mass which is equal to gram atomic mass, then it is called gram atom. For example, oxygen. What is the gram atomic mass of oxygen? 16 grams. Gram atomic mass of oxygen is 16 grams. Instead of writing this 16, simply we can write 1 gram atom. Definitions you need to understand. Gram atom. Gram atomic mass of any element is also known as 1 gram atom. Nitrogen you take, for example, gram atomic mass of nitrogen is 14 grams. So in place of 14 grams of nitrogen, in place of 14 grams of nitrogen, you can write 1 gram atom of nitrogen. In place of 16 grams of oxygen, in place of 16 grams of oxygen, you can write 1 gram atom of oxygen. 1 gram atom of oxygen. Calcium, if you take gram atomic mass of calcium is 40 grams. 40 grams of calcium is equal to 1 gram atom. And how to find the number of gram atoms? For example, some mass is given. Some mass is given. From that mass, how to find the number of gram atoms? How to find the number of gram atoms? So let me explain the simple formula to find the number of gram atoms. See, for example, here I am taking calcium. I'm taking calcium. But you are given 800 grams of calcium. You are given 800 grams of what? Calcium. But what is your aim? You want to convert this 800 grams of calcium into gram atoms. Into gram atoms. What is 1 gram atom? 1 gram atom is nothing but gram atomic weight. What is the gram atomic weight of calcium? 40. Of course, I will give you 1 to 20. Atomic number 1 to 20. All atomic weights you have to remember, right? But in this example, I'm giving that is 40. So, 40 grams of calcium is equal to 1 gram atom. 1 gram atom. But here in this example, how many grams are given? 800 grams. Then 800 grams of calcium is equal to X gram atoms. X gram atoms. So take cross multiplication. So that is 40 into X is equal to 800. Of course, this is 40 grams. This is 800 grams into 1 gram atom. Don't worry, 1 gram atom. So this gram gets cancelled, and X is equal to 800 by 40. So this is equal to 20 gram atoms. Like this, we have to find. So we got a formula. Every time we cannot take like this. Okay, conceptually you can do that, but if you know the definition. But what is X here? Number of gram atoms. What is the answer? 20. How did you get this? You divided 800. 800 was divided with 40. What is 800? Given weight. What is 40? Gram atomic weight. So what is the formula now? Number of gram atoms is equal to number of gram atoms is equal to given weight of atom. Which atom? It may be calcium or oxygen or nitrogen, whatever. Given weight of atom by gram atomic weight. Gram atomic weight. So that is the simple formula I have written here. That is the simple formula here I have written. The number of gram atoms, if you want to find, that is equal to given weight in grams by gram atomic weight. Let me take, for example, hydrogen. If you take, relative atomic mass of hydrogen is 1. You may get it out, sir, how 1? I told you already, I will give the list of atomic masses, relative atomic masses, 1 to 20, you need to remember. Beyond 20 means 100% they will give in the questions. Relative atomic mass of hydrogen is 1. Absolute atomic mass, how do you get? Please tell me. Absolute atomic mass is equal to relative atomic mass into AMU mass. Absolute atomic mass is equal to relative atomic mass. What is the relative atomic mass? 1 into AMU mass. Which scale we are using? Which scale we are using? IUPAC scale. IUPAC scale means what is AMU? AMU mass 1/12 part of C12 isotope. What is 1/12 part of C12 isotope? 1. But it should be in grams. Therefore, 1.66 into 10 power minus 24 grams, like this. But a gram atomic mass, already told you here, every time we cannot. Gram atomic mass is equal to relative atomic mass into 1 gram. Again, this should be multiplied by Avogadro number. You'll get 1 gram. Right? And oxygen, if you take, relative atomic mass of oxygen is 16. Absolute atomic mass of oxygen means 16 into 1 into 1.66 into 10 power minus 24. Why this one every time? That is the definition of AMU according to IUPAC. So absolute atomic mass of oxygen is 16 into AMU weight. AMU weight, how many AMUs? 1 AMU. So that is 1.66 into 10 power minus 24. And gram atomic mass means it is multiplied by, it should be multiplied by 1 gram. Otherwise, if you want to convert this into this, so this is the absolute weight of single atom, but we need the absolute weight of Avogadro number of atoms. Therefore, it should be multiplied by 6.023 into 10 power 23. If you multiply, you will be getting ultimately 16 grams. So this is about the complete clarity on atomic weight, relative atomic weight, absolute atomic weight, IUPAC scale, older scale, AMU definition, various terms of AMU, how to convert AMU into grams and kilograms, and what is the gram atomic mass, and finally number of gram atoms. The same concept we have to apply for molecules also. After that mole concept, after completion of mole concept, from lower level to higher level problems also we'll discuss. Lower level to higher level. But if you are the beginner, please go conceptually. Go conceptually. Invest your time and learn the subject properly. Right? So this is the end of this video. We'll meet in the next video with the continuation topic. Thank you. Thank you very much.